Hello, everybody. So I'm Pete. I'm a developer. By day, I do very back-endy stuff, so automating databases and things. But under the cover of darkness, I like to make things that people can interact with and see. And one of the great ways you can do that is with Meteor. So, big fan of Meteor. One of the projects I've been building for quite a while is this thing called Card Flash. It's like a flashcard learning app. I've kind of been building it on and off, and I started building it when I knew nothing about Meteor. So I didn't really know what was going on, just kind of trying out things, and it ended up being pretty complicated. I was looking at some bits of it. These are some parts of Card Flash, and when I started, I just kind of, I just needed a new feature, so I just created a new file, put in some logic in the file, maybe put it in client or server. But in the end, I kind of ended up with this big spaghetti mess because Meteor, as you probably know, doesn't enforce much kind of structure on the code. So that's basically, I have no idea what I'm doing. So I was like, OK, I've got to work this out. It started to get too big, too spaghetti. And I looked at how I can maybe structure it a bit better. And I found out about packages. And packages are the things you add when you do Meteor add something, kind of these small modular pieces of code that you can share and you can put in your projects. Packages are fantastic because they're very isolated. Code in the package doesn't have access to code outside the package unless you kind of tell it, unless you give it explicit dependencies. So it's isolated. You've got these explicit dependencies and exports. So you can say this code exports this object. And they're really easy to test because they come with free unit testing from the Tinytest package. And I think they encourage you to use small reusable objects, which is great. Cool. So let's look at how we can use packages. And so this led me to rewrite my project with the everything is a package approach. So in this talk, I'm going to talk about how you can make your project an everything is a package project, and how you can test your objects or your packages in an easy way and then tie them together. Cool. So to create a package, it's pretty easy. Just go to the command line in your project, and you just run Meteor create package, and you give the name of the package. So as an example, I'm going to create the dramatic logger package, which logs things in a dramatic way. Usually with packages, you namespace them with your GitHub username, and that makes it easy to publish them to Atmosphere, which is the Meteor package registry, like RubyGems. And then if you want to add the package to the project, just do Meteor add package. Cool. So that creates a few files. It'll create the packages folder, and it'll give you a packages.js, package.js, and it'll create some default files for you. Let's look at package.js. It kind of describes the package, basically. So you have a description, so it's called dramatic logger. You have a summary, you can have a Git repo, and then here you can define what your package depends on and what it exports, and then you have some testing stuff. So the dependencies and exports, you can do things like say, well, this package only works with Meteor 1.0.1. You can use other packages inside the package, like CoffeeScript. You can say you only want to use it on the client or on the server, and that's really useful if you have this huge Meteor app and you don't want to load code that you don't need on the server or on the client. You can say what files it uses, and then you can export objects that other packages can use. So now if I use this package, I know I have a logger object. Cool. And then for testing, you get this package.onTest function, and it uses Tinytest by default. I'm using CoffeeScript here. You import the package, and you can say what files. You have some test files. Let's see what a test file looks like. So this is the Tinytest test framework. I think it's really cool. One of the great things about Tinytest is that it's true to its name. It's really, really tiny. There's only a few methods. One of the bad things about Tinytest is that there's no documentation that I know of. If anyone knows any documentation, please let me know. The only documentation I found is the source code itself, which you can get to if you go to GitHub Meteor, and then look through the packages, find Tinytest. It's tinytest.js. But basically, it's pretty simple. You have two methods. You've got Tinytest add and Tinytest add async for asynchronous tests. And basically, you just do Tinytest add. You put your description of what you're going to test. You get a test object, and you make assertions on the test object. So things like test that 4 equals 4, or these things, basically. Cool. And then to run the tests, just run Meteor test packages, and that'll set up a test server, by default on localhost 3000, and you look at that, and it tells you all your tests passed, hopefully. And if you add the files on the server as well, it'll run them on the client and on the server. That's what the C means. Cool. So as an example, let's create this dramatic logger. So apologies about the CoffeeScript, by the way. I come from a Ruby background, so I can only write CoffeeScript. I can't write semicolons. So as an example, we'll create a dramatic logger. This is it. So we've got a class logger. It has a log method, which takes a message, and it'll log to the console the message in a more dramatic way. So to test this, what we might want to ask is, if I send a message to log, did console.log receive what I expected it to receive? So in Tinytest, we can do this like this. We create a logger. Oh, logs, sorry. Ignore that logs collection. That's a mistake. We create a new logger, and we'll say logger.log should. That's the wrong one. OK, sorry. Logger.log should do something, and then we'll trigger the behavior that we're trying to test, and we can use this spying framework called Sign-On. It's like a JavaScript spying framework, and that'll let you look at objects and see if methods were called on them and how they were called. So you can say, when I call logger.log, did console.log get called once, and did console.log get called with what I expected it to be called with? And then, so this sets the spy. It says, look at console.log and see what it's logging, and then this kind of cancels it. And hopefully that passes, and you get something like this. So notice that now the test runner has kind of namespaced the tests, which is really cool. Basically, in your test descriptions, you put dashes between stuff. It kind of groups them into groups of tests, which is quite useful if you have like 100 tests and you need to say, describe different things and kind of group them by kind of related things. Cool. And there's also the add async method. So there's only two methods on Tinytest, add and add async. And add async is for testing asynchronous things. And basically, you get a next object as well, and you just call next when you finish making all your assumptions, all your assertions. Cool. So Tinytest is really simple, but one of the problems is that these can get really, really long. Your test descriptions, especially if you have lots of nested descriptions. So if you want an alternative syntax, I made a package called describe, if you want to try that out. And that makes it more RSpec-like. I couldn't deal with that describe, so I had to make it like RSpec, so it just makes it more like that. And then you can nest these things, and your line length won't be so horribly long. Just search for describe on Atmosphere for that. Cool. So putting everything in packages lets you easily unit test objects. You can create small unit tested objects, and I think it's a good idea to have one class or prototype, if you're not using CoffeeScript, per package. And that's good because you just export this class, and your unit test kind of says this is what it should do under this behavior. Cool. So that's like a simple example where we're just testing, what does it output to the console. But in like the real world, you might want to test more complicated stuff. Usually you have collections involved. And I think collections are really, really good because they let you share state, not only between objects, but you can share the state between clients and from the client to the server. So often, one danger, I guess, of using small objects is that they're kind of all tied together. Like each object is kind of calling other objects. And what you can do is use collections to share state so that each object just speaks to collections. And that means each object just really has one dependency or just a few dependencies. It speaks to the collection, updates the collection, and then it does something when the collection changes. So all your dependencies kind of go through the collection. So how do you test the collection? Well, you could test it by using the spy like before, but that gets kind of complicated, especially if you're doing like complicated updates on the collection. So you might say, oh, check that my update, use sort and limit and all these things to get these complex updates. Maybe a better way is to create these to create temporary collections, right? So if we if we update the logger to take the logs collection, so we update the logger to take a collection, and we can say instead of writing to console, maybe this logger just inserts the message into the logs collection. Then we can test it using a temporary collection, and this means that we're not we don't depend on anything outside logger. We just pass in the collection when we instantiate the logger. So the way we can test this is create a new logger, test that it updates the log collection, clean up the collection before we run the test, trigger the behavior, so log error, and then just check that the message went into the collection. Cool. So write small unit tested objects, have one class or prototype per package, and you can inject the collections instead of depending on global variables. So often in like big Meteor apps, you might see collections just as global variables, and that's a smell because then you've got all this kind of spaghetti code. You don't know what might reference that. Whereas if you inject it within the constructor, it's much easier to kind of have this decoupled code. Cool. Yeah. So sometimes you might not need a collection to hold the state. Maybe a collection, you don't need anything as complicated as a collection to hold the state, right? You might just need have a template that reads your object and then responds to that and outputs the data of the object. So you can use reactive var in your little objects to have reactive state. So this is how it works basically. It's just a Meteor package. In your constructor, you can instantiate a reactive var, and then get can get the reactive var, and that's a reactive variable, which means that a template that gets this and displays data from this method will update automatically whenever it's set. So you can make these small objects with reactive variables, and they're really easy to test. You just create one, set something, do tracker.flush, which will make sure all the reactive computations run, and then just check that the right thing comes out. So reactive var for reactive states. And then in your templates, I'm definitely guilty of this. You get all kinds of complicated, you can see all kinds of complicated untested logic. Often a template will have some event, and maybe the event needs to do something if the user's logged in, or it needs to do some other logic if the user's logged out. And that stuff's never tested. So an easy way to test this is to create log views, basically. Sorry, is to create views. And these basically just have a helpers method and an events method. And this can be easily unit tested. It can easily be a package. You just inject your dependencies with Tinytest, put stuff in, make sure that the methods return the right things. And then you require the package in your project, and you just tie it all together like this. Cool. And that means that you're increasing the surface area of code that is unit tested, because it's really hard to test that thing, but it's much easier to test this. Cool. So put your complex template event helper logic to unit tested views. Cool, and I think that's pretty much it. So that's the everything is a package pattern. And I think it definitely helps. Yeah, it's basically anti-spaghetti code stuff. So cool, thank you.